This is a demonstration video for the CP329 Project 3 digital multimeter. So the first demonstration we'll do is a 1 volt DC value. And if you look at the DC voltage, it shows 1 volt. And if you look at the bar graph, it shows 1 volt as well. Next, we'll up the DC voltage to 2 volts and see that the DC voltage is up to 2 volts and the bar graph also goes up to 2 volts. Now if I switch over to AC mode by giving it an AC input, the first input I'm going to give is a 3 volt peak to peak sine wave with a 1.5 volt DC offset at 500 hertz. So as you can see, the DC offset is 1.5 volts, the peak to peak value is 3 volts, RMS is 1.85 volts, and the frequency is close to 500 hertz. And the bar graph also shows the DC offset of 1.5 volts and a 1.8 volt RMS value. Next I'll change it to a 1 volt peak to peak with a half a volt DC offset at 1 kilohertz. So 1 volt peak to peak with a half volt DC offset at 1 kilohertz. So again, you'll see the values update to the values and the bar graphs update to show the input wave. Next, I'm going to up the DC offset to 2.5 volts with the same peak to peak value and frequency. And as you can tell, the the DC offset goes up to 2.5 volts. Next, I will input a 3 volt peak to peak. A 3 volt peak to peak triangle wave with a 1.5 volt DC offset at 50 hertz. So if I change this to a triangle and change this to 50 hertz, you'll see the values update accordingly on the multimeter screen. And lastly, I'll demonstrate a 1 volt peak to peak square wave with a 1.5 volt DC offset. 1 volt peak to peak square wave at 10 hertz. And again, the values update accordingly. And lastly, I'll show some frequency specific signals. The first one I'll do is a 3.3 volt or a 3 volt peak to peak. Sine wave with 1.5 volt DC offset at 1 kilohertz. And as you can see, the frequency updates to close to 1 kilohertz. And now I'll demonstrate our lowest possible frequency, which is around 20 hertz. And I'll do that using a square wave with the same amplitude and offset. And apologize for my incompetence in using a function generator. And here I'm inputting a 20 hertz square wave, and it shows 20 hertz here, so I'm just going to slowly lower the frequency until at one point the multimeter will lose its ability to measure the frequency, and we'll demonstrate that real time. And it happens right there. So as you can see, the lowest frequency we can measure is 11 hertz, and that's due to the timer counter that we're using can only count to a value, a certain, the timer counter ends up wrapping over because the period of the lower frequency waves is out of bounds of its maximum count value. And that's it.